Welcome to today's class. Today again we are going to continue with the last class. It is the third part of inverse trigonometric functions. Okay, today we'll take a few questions. Let me start with evaluate sine 4 cos inverse of cos of suppose 5. You have to find out the values of this too. Okay, now this cannot be written as 4 simply because sine inverse of sine theta is theta only if theta is lying between minus pi by 2 to pi by 2. Okay, so this one 4 is not lying in that interval minus pi by 2 to pi by 2, so we cannot write this one to be equal to 4. Okay, now see 4, these are the radian values. The minus pi by 2, this one is can be thought of minus 1.58 approximately to plus 1.58. So unless I bring this 4, in fact sine 4 in that, I'll not be able to use this formula sine inverse of sine of x that day we have discussed with the graph. Okay, so what we'll do, we'll see where 4 lies. The trick of doing these problems are this: 4 is lying definitely between pi is 3.14 and 3 pi by 2, right? So I have to brought it to that interval. So what I'll do, I'll subtract pi, 4 minus pi. If I'll subtract pi from it, it becomes pi by 2. Pi from it becomes 0. Now this one, 4 minus pi, seems to be in the principal value range. This is a subset of this. 4 minus pi belongs to minus pi by 2 to pi by 2. 0 to pi by 2, which is now subset of minus pi by 2 to pi by 2. Now I can write, if the question would have been sine inverse of sine of 4 minus pi, I could have written 4 minus pi. Now all I need to check whether sine inverse of sine of 4 is 4 minus, this inside value is 4 minus pi or not. So we know that sine of pi minus 4 is sine 4, but I am getting 4 minus pi. Okay, so what I'll do, I'll use one more trick here. So if I do multiply a negative 1 in both the sides, in all the three sides in fact, I'll get minus pi by 2, pi minus 4, still it is a subset of this. Okay, now 4 minus pi is lying between minus pi by 2 to 0, no problem. Minus pi by 2 to 0, still it is a subset of this. So therefore sine inverse of sine 4 will write sine inverse of sine of pi minus 4, because I know that sine of pi minus 4 will give me 4 again. And since now I know pi minus 4 is lying between minus pi by 2 to 0, which is a subset of the principal value range, that is minus pi by 2 to pi by 2, so I can write this one to be as pi minus 4. So that's the result. Again, this is what we have to check all the time whenever we are using cos inverse of cos x, sine inverse of sine x, tan inverse of tan x, etc. Okay, I'll go for a second question. Again with the same logic, cos inverse of cos 5 definitely will not be equal to 5, because this result is true only for the values which are lying in this interval. Let me write down the principal value branch of cos inverse, that is 0 to pi. So 5 is definitely not lying there. So what we'll do, we'll check where 5 lies. 5 is lying between pi and 2 pi. Yes, pi and 2 pi. Okay. Now 5 minus pi will lie between 0 to pi. It seems to be the principal value branch. 5 minus pi is lying in 0 to pi. It seems to be the principal value branch. But the problem is, cos of 5 minus pi is not cos 5. Okay, so what we'll do, we'll write another trick. We'll use another trick. Minus pi is pi minus 5. It's lying between 0. Minus pi minus 5 is lying between minus pi and 0. And we add 1 pi. 2 pi minus 5 is lying between 0 to pi. Still 2 pi minus 5 is lying between 0 to pi. Now you check cos inverse of cos of 5. This cos 5 now can be written as cos inverse of cos of 2 pi minus 5. Cos of 2 pi minus theta is cos theta. So we have brought not only the angle, but also we have seen that that angle is lying in the desired principal value branch, so that I can use that result. And that is the trick of doing this kind of question. 2 pi minus 5. That's the answer. So you have to take care of both the situations. Okay. Let me do one more question on 10. Tan inverse of, suppose, tan of 4. Again, I cannot write simply this one as 4. This is wrong. But check where 4 lies. 4 is lying between pi and 3 pi by 2. One thing you notice, whenever I am doing with tan inverse and sine inverse, I am using that one of the value as 3 pi by 2, that odd multiple of pi by 2. Again, because its principal value branch is like that. And whenever I am doing for cos inverse, I am using pi, because principal value branch is like that. Again, that is another trick, another thing to ponder upon. Okay. Now, this one has to be brought into the principal value branch. The principal value branch of tan inverse of x is minus pi by 2 to pi by 2 open interval. Okay, so let us subtract pi from it. I get 0 here, 4 minus pi, and here I get, if I subtract pi, we get pi by 2. Now this one is a subset of the principal value branch. Now we'll work on this. Tan inverse of tan 4 is equal to tan inverse of minus tan pi minus 4. We can write tan of pi minus 4 is minus tan 4. Minus minus, it will become plus. So I'll use here another step to get minus pi by 2. Pi minus 4. Still it is a subset of this. So tan inverse of 10 of 4 minus pi, sorry, 4 minus pi, I should have written this one was correct. It will become 4 minus pi. So this will be the answer. This one is not required here. Okay, we have used the fact that tan of minus theta is minus tan theta. Please check again. Tan inverse of tan 4, definitely not equal to 4 because 4 is lying here, not there. It is desired to be lying here in this interval. Now we have checked that 4 is lying between pi and 3 pi by 2. We have brought it down to that interval or any subset of that. We have subtracted pi from both the sides, means all the three sides, 0, 4 minus pi and pi by 2. Now we have used this fact, tan inverse of tan 4 can be written as tan inverse of minus tan pi minus 4. Okay, tan pi minus 4 is minus 4, right? Tan of pi minus 4 is minus tan of 4. Minus minus plus tan of 4, so we'll be getting this only. So tan inverse of, again we have used here what? Tan of minus theta is minus tan theta, so we have minus tan theta, we have made it tan of minus theta. So 4 minus pi. 4 minus pi was lying, it was belonging to that minus pi by 2 to pi by 2. So we can use now 4 minus pi. Find the smallest positive integral value of n for which n minus 2 whole into x squared plus 8x plus n plus 4 is greater than sin inverse of sin of 12 plus cos inverse of cos of 12 for all x belongs to R. Now this seems to be a question combination of quadratic equation and inverse trigonometric function. So first of all, let me tackle the right hand side part of the inequality, which have sin inverse of sin 12 and cos inverse of cos 12. So let me evaluate first these two separately. The sin inverse of sin of 12, definitely it is not going to be equal to 12. So we'll check where 12 lies. 12 is lying between 4 pi out here, that is 12 point something, and the next immediately lesser than this value will be 7 pi by 2. Okay, now then we have to brought this one into the principal value branch of sin inverse, that is 12 minus 4 pi value to the minus pi by 2. So 4 pi minus 12 will be lying between 0 to pi by 2. Both of these are lying in the principal value branch. Now we'll check which one is required, okay? Using this sin inverse of sin of 12 or sin inverse of sin of 4 pi minus 12. Now please understand, 4 pi minus 12, fourth quadrant, where sign is negative, so if we give you a negative value, so in order to maintain the equality, we will give negative sign. So sin inverse of this one will go inside, becomes sin 12 minus 4 pi. Not a problem, because this one is also lying in the principal value branch. 12 minus 4 pi is lying between minus pi by 2 to 0, which is a subset of the principal value branch of sin inverse, so not a problem to write 12 minus 4 pi. So this one, sin inverse of sin of 12 is giving me 12 minus 4 pi. If we check what cos inverse of cos of 12 give me, the 12 here it is lying between 3 pi and 4 pi. So 12 minus 4 pi will be lying between 0 to minus pi. 4 pi minus 12 will lie between 0 to pi. Now this one, cos inverse of cos of 12 can be written as cos inverse of cos of 4 pi minus 12. We'll check 4 pi minus 12, it is in the fourth quadrant, cos is positive, so it can be written. So cos inverse of cos of 4 pi minus 12. 4 pi minus 12 is lying in the principal value branch of cos inverse, that is 0 to pi. So generated is 4 pi minus 2. Therefore, the inequality reduced to n minus 2 whole into x square plus 8x plus n plus 4 is greater than 12 minus 4 pi plus 4 pi minus 12 is nothing but 0. That is n minus 2 whole into x square plus 8x plus n plus 4 has to be greater than 0. Now we know that a quadratic polynomial becomes greater than 0 only if the coefficient of the highest power is positive and the discriminant d is negative. Okay, so discriminant will be b squared, that is 64 minus 4 into n plus 4 into n minus 2 has to be less than 0, implies n is greater than 4, sorry. Okay, n is greater than 4 and n is less than minus 6. So one is saying n is greater than 2, n is less than minus 6 is invalid because we are talking about positive integral values, so we will go for n greater than 4. This one is saying n greater than 2, so intersection is n is greater than 4, and we are looking for the smallest positive integral value of n, which is n equal to. Okay, so we'll do a few more properties. We'll discuss few more properties in the next class. Then we'll go for some more questions like this. Okay, until then, thank you.